We're interested in finding solutions to trigonometric equations. But before we do that, we want to look back at the basic geometry of solving equations in general. So let's take a basic linear equation like this. 2x plus 3 equals 8. So what's going on with this? Well, we can take this and we can manipulate this to solve, subtract 3, divide by 2, and solve for x. But we're interested in what's happening graphically to this thing. What is happening here? So what we have is we have two equations. We have y equals 2x plus 3, and we have another equation, y equals 8. And we are looking for the intersection of these two graphs. Now you may not have actually seen it set up this way, but this is something that we can set up in the background and understand, yes, this is what's happening. We're looking for where these two things, where y is equal to y, where 2x plus 3 is equal to 8. And we can draw this graphically. So first we have our line 2x plus 3, which is something like this, and then we have the line y equals 8, like this. So that's y equals 8. This is y equals 2x plus 3. And there's a point of intersection there. And we're interested in the x value that gives us that point of intersection. And if you do all the work, you'll find that this is 5/2, subtract 3, divide by 2. But what we're looking for here, the solution, is the x coordinate that gives us the location of that point of intersection. And the reason why this matters is because when we solve trigonometric equations, we're going to be doing something very similar. What we're going to have is we're going to have some equation of the form, sine of x equals 1/2. Well, what does that mean? Well, here we have the graph y equals sine x, and then we have the graph y equals 1/2. And so when we look at the solutions, what we're looking at the sine curve. Right, the sine curve starts at 0 and starts going up to the right, and then on the left side it goes down. And we're looking at the line y equals, well, I didn't quite squeeze it in there, y equals 1/2. Now there's a couple things to notice here. First thing to notice is that there are lots of intersection points. In fact, there are going to be infinitely many intersection points. But we are interested in the x values that corresponds to all of those points. And that's what it means to find solutions to a trigonometric equation. Where are those points of intersection, and specifically what are the x coordinates of those intersection points? There's another way to look at the solutions of trigonometric equations using the unit circle. So the unit circle of radius 1, we have some angle theta that's going to go around the circle, and we're going to look for points here. But what points are we looking for? Well, let's say we have the equation sine of x equals 1/2. What does this mean? The sine function corresponds to the y coordinate of the unit circle. And so since this is the y coordinate, we are looking for places where the y coordinate has a specific value. So this is the line y equals 1/2. And we're looking for those points of intersection. Now remember that when in the setup here, we are looking for angles. X is going to be this angle here. It's going to be this angle here. But it's not just those angles. It's also the angles that are coterminal with those angles. And we know that coterminal angles differ by 2 pi radians or 360 degrees. And so once we get this first one, we also have to take into account that there are angles coterminal to that, both in the forward and the backwards direction, that give us other angles that will return us back to this point. And so we're going to see this when we actually solve these things explicitly. But right now, conceptually, it's really important to understand this is why we see multiple solutions. We have a solution in quadrant 1 and solution in quadrant 2. That's one type of multiple solutions, but we also have multiple solutions coming from the fact that we have coterminal angles.